This video is to look at the production possibility curve, sometimes known as production possibility frontier, and also to introduce the topics of comparative and absolute advantage. So this is a simplified model of a country, it could also be a company, individual that produces two goods. So on the macro level, you have axes, and a company can produce two goods. Well, the typical curve is going to be a bowed out curve as opposed to a linear curve, and we'll look at the reasons as to why that is true in a moment. So first of all, just a quick introduction to the topic. These points A, B, and C that are on the curve, think of this as a boundary. These are all efficient points. So this, for example, country is only making TVs or shoes. This is the boundary. The country, if they use all their resources most efficiently, all the workers and materials, they don't waste any, they can produce any point on this curve. But it's a trade-off, because obviously the more shoes you produce, you need more materials, more workers to produce shoes, and therefore less TVs, and vice versa. Any point outside the curve, for example point G, is not obtainable with today's technology resources. Any point inside the curve, the curve, for example point E, is a point that is obtainable but is inefficient, that we're not using our resources or the workers most efficiently. That clearly is not desirable. So the concept of opportunity cost looks at what one has to give up, the next best alternative that one, when one makes a decision, what are they giving up? So if we look from C to B, I could have gone B to C, but here we're going from C to B. So the question is, what do we lose and what do we gain? Well, we're losing shoes. So we're going to put that in the numerator of a fraction. So we're going to give up 100 shoes, and we're at the letter S for shoes. And what do we gain when we go from C to B? When we get from 4 to 6, so we gain 2 TVs. So just simplifying that fraction, so it's going to be 50. Of course 50 is 50 over 1, so that should make sense. So it's 50 shoes per TV. You don't need to put the 1 down there, but of course that should make sense. So if you want to go from point C to point B, if you want to gain TVs, you will have to give up 50 shoes to gain 1 TV. And just to make the math better, I'm going to change one value on the y-axis, the TVs appears to be an 8. I'm going to cross that off. You can see where I am doing this, and make that the value 7. So point A going across corresponds to 7 TVs and 100 shoes. So the same token, going from point B to point A, what's the opportunity cost? What do you have to give up? Well, we are losing shoes, we're gaining TVs. So if we go from B to A, I'm going from 6 to 7 TVs. So I'm going to give up those same, in this case, the scale can be different, but I'm giving up the same 100 shoes, but I'm going to gain 1 TV. This is already simplified, so it's 100 shoes per TV. And this is describing what's called as a law of increasing opportunity cost. Anytime there's a bowed out PPF, which is typically the case, you're always going to have an increasing opportunity cost, meaning the more you want to gain of one good, you'll have to give up more and more of the other good if you keep wanting gaining more of that first good. And that's because the resources have to be substituted, and the best resources were going to be used initially for that production. Later on, we're going to become less efficient as we shift over. But contrast that with the example at the bottom of the page, which is linear PPF. This is less typical. Most goods operate according to that bowed out PPF, but look at the products they used here. TVs and shoes, they're going to use different resources, different workers, different skill set. But the products I did here, corn and wheat, we figure the farmers who are going to involve in that production, if they can produce corn, wheat, the skill set's the same, the land, the resources, the water, pretty much everything is identical. So therefore the opportunity cost is going to be constant. It's linear. Well, just as we know a slope of a line has the same slope, well, this is a different concept, but so too here. If we move at any point along the curve, the opportunity cost, unlike the example above, which has a law of increasing opportunity cost, this is going to be constant opportunity cost. So if we go from point F to point E, same thing is, so what do we lose and what do we gain? So we are going from F to E, we are losing wheat, so we're going to lose 80 wheat, but we're gaining 40 corn. So the opportunity cost is 80 over 40, so it's going to be 2 wheats per 1 corn. And that would be true at any point if we go in the same direction. So this point G, new G in this graph, if I go from F to G or F to H or G to H, if I go up that curve, it's a constant opportunity cost. It's going to be always 2 wheat per 1 corn. Okay, the concept of specialization in trade, very important in the global economy. The U.S., of course, can produce, pretty much because of our vast resources and climate, we can produce many, many goods. But of course we know we import a lot of goods. We could produce, I guess, all the TVs and cars that we want, but we have a lot of other countries producing that. Sometimes countries or companies or individuals will only specialize and produce one product. So the question is, why is that? Well, you figure it's in our best interest. You're only going to trade if you can be better off. So on the macro level, here's a country that produces 2 goods. We looked at the efficient points on the curve, on the boundary. So perhaps this point I called G before, outside of that point may not be obtainable without trade with our current resources and materials, but perhaps with trade we can reach points that are outside our curve. The key concept that allows us to do this is comparative advantage. That's the basis of trade. And if any person or country or company can produce at a lower opportunity cost, meaning they have to give up less than someone else when they make something, they are said to have a comparative advantage in that job. This is different than absolute advantage, where one is just more productive, producing something. So they can take less time, or with the same amount of resources, they can produce more. In either case, that person or country or company would be said to be more productive. They're at an absolute advantage. And the classic example to illustrate this distinction is that between the boss and the typist. Typically, we would think a secretary can type faster than a boss, but for this example, we'll assume the boss, who's a lawyer, is also a very good typist. In fact, he or she is the best typist in town, and the secretary that I would hire, who's maybe a paralegal, who can prepare legal briefs, can also type. But in this case, looking at the numbers, comparing the boss to the secretary for each job, the boss has the absolute advantage in both typing and preparing legal briefs. The boss can type 10 pages, the secretary only 6 in that same hour, and they can do 3 legal briefs versus 1. This isn't always the case where one party has it in both. Clearly can be. If one party has it in both, then of course the other party has it in neither, or it could be that each party has it in one of the two. Completely different is the comparative advantage. So I want us to compute the comparative advantage for each service. Well, comparative advantage, we'll look at computing the opportunity cost and then compare who is the lower opportunity cost. So we're going to look at it from the lens of typing. So I want to know, with respect to typing, what is the boss's opportunity cost of typing? And then we'll look at the secretary's opportunity cost of typing, realizing that opportunity cost is what you gave up. So if I say what's the opportunity cost of typing, we assume in that party is typing. So if the boss is typing, what are they giving up? It's going to be what they lose divided by what they gain. So they're going to give up 3 legal briefs for the 10 pages typed. So 3 over 10 is 0.3. So it's 0.3 legal briefs. 0.3, of course, is 0.3 over 1. So you could say it's 0.3 legal briefs per page typed, but of course that is implied to be 1 page typed. If I ask what is the secretary's opportunity cost of typing, once again by asking that, the secretary is typing, so what did he or she give up? Gave up 1 legal brief for the 6 pages that they typed. So 1/6 as a decimal is 0.16 approximately. So 0.16, of course, is 0.16 over 1, so it's 0.16 legal brief over 1 page typed. So now we can say, well, who should do the typing? Well, it's the party who has lower opportunity cost. Well, since 0.16 is less than 0.3, and the party who has the 0.16 is the secretary should be doing the typing, and that implies that the boss should be preparing the legal briefs. I want you to take a moment and I want you to compute the opportunity cost for preparing legal briefs for both the boss and the secretary. And you can come back. Okay, if you've done that, your answers, which should make sense, look at the answers we had before and look at your answers. Well, for the boss, when you did the opportunity cost of legal briefs, you probably had 10 pages typed over 3 legal briefs. And notice, that is the reciprocal, which should make sense because we're going the opposite direction. So if I ask the opportunity cost of preparing the legal brief, the boss is going to be 10 pages typed over 3 legal briefs, which is 3.3 repeating type over 1 legal brief. And if you look at the secretary flipping it, or just doing it the other way as you did, it would be 6 pages typed over 1 legal brief. So the question, who has the lower opportunity cost? Well, 3.3 is less than 6. The boss does, so therefore the boss should be doing the typing. And this should make sense. Although one can have an absolute advantage in both products or services, that is not the case for comparative advantage. It's due to the nature of reciprocal numbers if the values are positive. If one has a comparative advantage in one good, the other party has to have a lower comparative advantage, lower opportunity cost in the other. So, how can they benefit in trade? Well, there is a value to compute to say what the trade-off should be, but in this case we know that the boss should be doing the preparing legal briefs and the secretary should be doing all the typing. On to addition. Okay, these are still outputs. So you can look at for maybe the same number of inputs. So if the U.S. has a certain number of workers and Brazil has the same number of workers, the U.S. can, let's say, produce 30 units of coffee, Brazil can do 20, and the U.S. can do 30, Brazil can do 10. So in this case, who has the absolute advantage? Well, the U.S. is going to have the absolute advantage in both products. Once again, it doesn't have to be, just the way these numbers. So just because you have the absolute advantage in both, does that mean the nations or the individuals should not be able to trade? Well, as we know from the prior example with the boss and secretary, the answer to that is no. So we are now going to compute the opportunity cost, let's say, of typing. I'm sorry, back to the other example. Let's do the opportunity cost of producing wheat. So if you want to try that on your own, put this on pause. So I want you to compute the opportunity cost of wheat. That means Both countries are producing wheat. What do they have to give up? And see who has lower opportunity cost, if you can figure that out. And then come back. Okay, so if we look at the US, if we ask what's their opportunity cost of producing wheat, once again they are doing wheat. So what are they losing? Well, therefore they're losing, not producing the 30 coffees for those 30 wheats. So the US has a opportunity cost of wheat of 1 coffee per 1 wheat. Whereas Brazil, what's their opportunity cost of wheat? So once again, they are producing the wheat. So what are they not producing? The coffee. 20 coffees per the 10 wheats. So therefore, simplifying that fraction, that is 2 coffees per 1 wheat. So as before, who is the lower opportunity cost? Well, 1 is less than 2. So therefore the US, since the US has a lower opportunity cost, 1 is less than 2, the US should be producing the wheat. Immediately, what does that mean about Brazil? Well, Brazil has to be producing the other good, which would be the coffee. And if you compute it, and these numbers are easy, if you computed it, take your time to do it, you would just reciprocate those numbers. So if I wanted to know the opportunity cost for coffee, well, if we reciprocate the US's values of 1 coffee per 1 wheat, well, that's easy. That's going to be 1 wheat per 1 coffee. And Brazil, if we reciprocate the original value of 20 coffee per 10 wheat, that's going to be 10 wheat per 20 coffee, or simplifying to be 1 wheat per 2 coffees, or 0.5 wheat per 1 coffee. Right, because 2 flip becomes a half. So who has a lower opportunity cost? Well, since 0.5 is less than 1, Brazil has a lower opportunity cost of producing coffee, so they should be producing coffee. Okay, this is very different, and you have to watch out for this. The same concept, but here we're looking at time. These are not outputs. So when dealing with outputs, bigger numbers are better, right? It's better to produce 30 than 10. But with time, less time to do a job is better than more time. So you have to watch out. So notice these are inputs. The input is time, how much time it takes. So you have to treat this a little differently. The absolute advantage part is easy. Think who's more efficient. Well, we have 2 people, Susie and Bob. Well, it looks like Susie is definitely faster than Bob in both jobs. So Susie has the absolute advantage. She can fix a computer in only 2 hours. It takes poor Bob 24 hours. And to paint a house, it takes Susie just 30 hours, and it takes Bob 48 hours. So the question is, who has the comparative advantage? Well, let's look at it from the construct of a computer. So let's look at who is opportunity cost, lower opportunity cost to repair a computer. I'll just call it a PC. Well, let's look at Susie. So you have to be careful. So if Susie's repairing a computer, opportunity cost, so she's fixing the computer. So that means she's spending those 2 hours fixing the computer. So what did she give up? Well, those 2 hours. What could have Susie done instead? She could have spent those 2 hours painting a house. The way I think of this is the answer more than 1 or less than 1. So she fixes the computer. She spent 2 hours on the computer. Well, had she put that time in painting the house, would she have painted more than one house, less than a house? Well, it takes 30 hours to produce a house. She only gave up 2 hours, so therefore she didn't do 2 of the 30. So what she gave up is she gave up 1/15 of painting the house. On the other hand, Bob, if Bob fixes a computer, so he spent 24 hours doing that, well, how much of the painting of the house did he do? More than one whole house or less than a house? Well, it takes 48 hours for him to paint the house. He used 24 hours painting, fixing the computer, so therefore it's less than 1. So the fraction will be 24 over 48, which is going to be 1/2 a house. So once you've done this, then the same part is true as before. Doesn't matter input, output, lower opportunity cost. Well, 1/15 is definitely less than 1/2. So since Susie has the lower opportunity cost for fixing the PC, Susie should fix the PC. And therefore, of course, Bob should be painting. If this was a multiple choice question, then I would say just look at it numerically. So let's look at repairing computer. 2 hours and 24 hours. Well, Susie, I think it's easy to say, is 12 times faster than Bob in fixing a computer. You know, when painting a house, even though she's faster, she's not, right, less than twice. She's not even twice as fast. Well, would you rather have the person do something if they're 12 times faster or just 1.5 times faster? Well, 12 times faster hopefully is the answer you've thought about. So therefore we look at it, and sure enough it looks like since Susie's 12 times faster than Bob in fixing the computer, Susie should be fixing the computer, and of course that's what it is, our answer. But if this wasn't a multiple choice, you need to go through the work as I just did with you and justifying using your unit. And lastly, the practice problem, you can work through this and you can check with me for the answers.